10.1 today. We did not get to do these examples yesterday. This is exactly where we're going to start today. Because this is your warm-up. I know it says it. This is your warm-up. So, really quickly, just because some of you haven't yet learned how to use your notes as a resource, as a really good resource. You've learned how to use your phone or other people as resources, but you haven't learned how to use your notes, some of you. Let me help you use your notes as a resource. I want you to turn back in your notes yesterday to where we wrote the word domain on the left. Remember, we write important words on the left and info describing on the right. Let me show examples on the right as well.
Yes.
We wrote the word domain. What did I say as far as how to find the domain of a square root function? Radicand, good.
Whoa.
Keep going. The radicand. What is the radicand? Not the square root, but the
the number, the variable, the thingy.
Yeah. And yesterday I just made it the box, right? Whatever's underneath. We can call it the expression. Okay. We can call it the expression. It might just be a variable. It might just be a number, but that wouldn't really be a square root function because there's not a variable. Anyway, we just call it the radicand, the box, whatever's underneath, whoever's in the house. Good. So, you're going to start by taking whoever's in the house, the radicand. You're going to be setting it greater than or equal to 0 and solving. Graph. How do we graph these square root functions? Make a table. Take x's, strategic x's, that have nice answers. Makes everything equal. Pick strategic x's, find y's, plot the points, and see what's going on. It's going to swoop, but it's only going to swoop up. Let me say it this way, it only goes further in one direction, right? It stops somewhere. And that's how we describe the range, which is also limited. I want you guys, even though there's two up here, can we see if we can do number one? Start with domain. Radicand greater than or equal to 0. Ready, set, and go. Once you have that, go ahead and try to fill in the table. Once you have that, try to make a graph. Once you have that, see if you can answer the range. How low is it double quickly? Should be able to. How low does it go? I'm going to go ahead and really quickly freeze the screen. Alright, go. Square root, you see how it's concave down like a frown? Whereas exponential is concave up like a cup. Concave up goes faster, quicker increase, whereas square root goes slower increase. So it's always, it does go up, but it doesn't go up in the same way. So when you have a concave up graph, it's going up quickly, whereas a concave down graph goes up slowly.
Oh, so if this is the line, the square root would go like that?
Yeah. Which is going up, it's slow. Exponential is like this. That's the much. Oh, it is up there. Oh, there we go. Okay, so then coming on back. Part of my examples missing. Some of you have gotten far, some of you have gotten somewhere. The question is, did you let yourself get somewhere? I gave you the first direction if you were in yesterday's class, you could look in your notes. Some of you can start getting a highlighter out because then it can take your attention quickly to where you need to look for homework and things like that. Okay? Let's focus. So yesterday in notes we talked about the radicand. The radicand was whatever is underneath, as you guys told me, the radical. So what was underneath in this one? X plus 5. Okay? And as Aiden was saying, and as some of you found in your notes, we said, it's okay, stay focused. Okay? We take what's underneath, x plus 5, and we set it greater than or equal to 1. And that's exactly from our notes, exactly where we had it yesterday. Okay? We take the radicand, see where I highlighted, set it greater than or equal to 0. So then coming on back, we need to go ahead and get x alone. And some of you guys already figured out in algebra, how do we move a plus 5? Up 5. Subtract 5, there we go. I need to subtract 5 from both sides, and when we subtract 5, show your work carefully. We add a little d for domain, and then we box it and say no big deal. How many of you guys did at least one of those problems last Okay. Did it help you? Raise your hand again if it helped you kind of remember for today. Almost everybody here raised their hand. Now, those of you that didn't try it last night, you already handicapped yourself because you didn't get to practice it a little. So speaking, you gotta practice on your homework because that way it'll stick. It'll stick better than if you don't do it. I'm not saying you have to be perfect. Just try. Just try. Now, Jay was saying earlier, this one's kind of hard for the table. This one's kind of hard for the table. Kiddos, remember how we need to start plugging in an x? And we're plugging the x's into the radicand. Specifically, we're plugging it into where the x is in the radicand. Question, could we start with 0?
Yes.
We
Yeah.
could.
Yeah, but
0 plus 5
Five.
works, but square root of 5?
4.
That's not good. So, could we go to 1 or 2 or 3, but it just keeps on getting bigger. Wait, we need to figure out when this is 0. Guys, look at the domain. It says x is greater than or equal to who? -5. So if I were you, I would say, okay, then maybe I should start at -5. The domain helps us. The domain helps us where to start in our table. The domain says x is greater than or equal to -5, so I'll start there. And what happens if you plug in -5 into the x spot? And I go ahead and zoom in. Do you guys see why I put parentheses where I put them? Yeah, that's exactly where I'm putting the x, right? So I'm going to put a -5 in there for this example. -5 plus 5 is 0. Square root of 0 is 0. Perfect. That works. I can do that. Now, could we try -4 next? Maybe. If we plug in, we have -4 plus 5. Is that something I can work with? -4 plus 5 is 1. And the square root of 1 is 1. Okay, I can do that. Right? Now, some of you might be able to do this a little bit easier than others, but let's just try. If we plug in -3.
2.
Oh, do we like square root of 2?
No.
I like square root of what?
4.
4. Can anybody figure out what plus 5 makes 4? -1. Now, once again, some of you, if you get a square root of 2, you might just find the decimal, and that's okay. You can try to graph that on a graph. That's not a bad thing. I'm just saying if you can find the really nice ones, it just makes it easier when we go to our graph, but it's kind of harder to find which ones are nice. But -1 plus 5 is 4. Square root of 4 is 2. It's just a little nicer of numbers. But if you had square root of 2, just use your calculator, get a decimal.
What if it's in the radicand on the inside, what if it was x plus 10? Would you go 10 and then 9 and then 8?
Well, the domain for x plus 10 would actually be, you move the 10 over, it'd be -10. So we do -10, -9, then we probably skip up a few,
I got you.
like we did
But
here.
it'd go down like that.
Can anybody find the next nice one that we like? We like
4.
square root of 0.
4.
We like square root of 1. We like square root of 4. What would be the next square root we like? 9.
5.
And Diego already was like, well, wait a minute. What plus 5 is 9? 4. So we could use 4. Does that kind of make sense? It's like we're filling the hole. We have something plus 5 makes 9. Oh, 4 plus 5. Now, guys, we can keep going, but I'm pretty sure that's enough points to get
It was, wasn't wide.
This was 139.
Oh,
Yeah,
square
that's
root of
nice.
is 3. Thanks, guys. Wow. It's a Friday even in my head, huh? Okay, Jordan.
I did like start with negative numbers.
Okay.
So I did 4 and not 3, and then I did 11, 4, 25, 31, 6.
Okay.
Is that still okay?
It would be okay. The problem is you're only going to see part of your graph, and here's the reason why. A square root function starts at a point and goes up. You're going to just kind of see this little up, but you're not going to know where it started, so you wouldn't know exactly how to draw like the whole thing. Does that make sense?
So do I need to find a negative number?
I would say find a domain first, because the domain tells you, hey, start here.
Because the domain is like as far as where I can go. Okay.
Does that make sense? So then when we go to our graph, we can go ahead and plug in these. Let's see, -1, 2, 3, 4, 5. How high did we go? Oh, positive 1, 2, 3.
X equals 139.
This just got really big. I guess you could, yeah, I guess so. That's just gonna get a lot higher. Oh, that's a good catch though.
Are we recording?
Yep.
Okay.
Yeah. Yeah, thanks for checking though, I appreciate it. We have 0, 1, 2, 3. I'm just getting my y's real quick. Let me graph my points. But as I graph, Jordan, do you have any questions that you?
Yeah, so if on a test, like, I forgot to do, put the domain.
I would probably ask you for the domain first. Usually on questions in the test, I like ask them in order to help you. So I'd probably ask kind of like this. I would say find the domain, that'd be like A. Graph it would be like B, and then describe it like this.
So I wanted to run the pocket.
As long as you realize if I have the domain, oh, I can use that. As we come back here, we have -4, 1. -1 is 2, and 4 is 3. You guys remember, only go forever in one direction, right? Now that we're looking at the graph, you need to ask or answer one more question. First question was, what is the domain? The second question is, graph with the table. Check, check. Third question is, describe the range. Y, good, you're good. Rangy, we're doing Y's. Greater than or equal to, how come? Because the graph goes up, right? So greater than or equal to. And Barry and Justin are trying to help us. What's the lowest Y's can go? 0. Now let me help. Look at the y-axis, cool kids. Do you see how there are no y values? There are no points for these y's. Look at this whole line, no points. Look at this whole line, no points. Look at this whole line, no points. For y equals -1, -2, -3, no points. The last y to get a point is y equals 0. So therefore I say y is greater than or equal to 0. How low does it go on the y-axis? It goes to 0 and it stops. Remember, how low does it go? That's for our range. And then, how left can you go? In this case, that would be our domain. It goes left to -5, which is why you see that shown here, and it goes down to 0, which is why you see that. Okay? Now that we've worked through one entirely, can I just kind of walk around the room and you guys do number 2 if you haven't yet?
Okay.
But as I do that, can we first just really quickly talk about what's the radicand for number 2?
2x.
Radicand is 2x. So I'm just going to start off, and then I'll let you guys go. How do I do domain? Well, we start by writing the expression 2x is greater than or equal to 0. J divided by 2 is a great idea. Ready, set, go. Let's see how far we can get. And if you're stuck, I can answer questions.
Under 7.
You don't need the 7 for domain, but you're going to need it when you plug in for range. Do your steps, just do your steps. Oh, you did. Question?
See you later, John. See you later. All right.
Aiden, you should be looking under his hand. Guys, don't waste time. The whole point is I'm trying to come around and help, but if you guys can't take that, then I guess I just have to stop helping. And that means stop helping on tests too, and quizzes, and questions. So let me help. Try the problem. I'm coming. So where you're gonna start is where you're
Say 0 and 0 plus 7. Add 7 to 0. And right.
Anything divided by 0.
Zero.
I just started.
Two times zero is what? Alright, it's plus seven.
When is that gonna start then?
Monday.
Cerdo.
Oh, you already got
For
it.
president, I'm coming, guys.
Oh, that one was good.
Two times zero. Two times zero is zero. And then square root of zero is zero.
Have you guys all divided by 2 for the domain?
Zero.
And what'd you get for your domain?
Excess.
So then if x is greater than or equal to 0, then where do you start in your table for the first x? 0. Now. Well, you gotta plug in, right? Hold on, let me show that. You guys are all by that. Some of you are ahead. Okay, go ahead.
So it's zero, right? We plug in x, so it's 2x and 0 to 0. With radical 0 you add 7 to 0 first before you radical.
The radical is like PEMDAS. Hold on.
So you do
The radical is like parentheses, it's like grouping symbol. So let me go and show you guys, I think a lot of you have gotten about to this point.
So would it be 2 times 0 plus 7?
Yeah. Now we have to be careful, Caleb. When we go to plug in, we have 2 times 0, but we also have a plus 7. Now, hold on, PEMDAS, just in case you're stuck, Ian, I'm trying to help right here, hold on, pause. Oh, you see it? Coming back. You guys saw me put 0 in the right spot, right? Promise. So PEMDAS says grouping symbols first. The radical is a grouping symbol. I know it doesn't look like parentheses, and it's not, but it is still grouping. Remember how I told you with fractions, the top and bottom are grouped, they're grouped together? So we start inside the radical, and we do our multiplication. So then in going proper order, we would say 2 times 0 is 0.
0 plus 7 is 7.
Then we do square root of 0 is 0. And 0 plus 7 is 7. Did anybody keep going to plug in another point? This is where it gets hard. Oh, same thing, you plugged in 2?
Oh, I see.
Oh! Now, can anybody think of, we have square root of 0 is 0, and then plugging in 2, you get square root of 4, which is great. It is a good answer, and it does work. But can anybody think of, there actually was something in between you could have plugged in, not 1, because 1 times 2 is square root of 2. But you're close. 1 half. If you plugged in 1 half, what's 2 times 1 half? 1, square root of 1 is 1. But I'm trying to prove the point that you don't have to necessarily pick the perfect point. If you plug in 2, square root of 2 times 2 is a nice square root. We get square root of 4. And what is square root of 4? Yeah, you see it? So this works. 2 works, but you could have also done 1 half. I'm just letting you know that's the thing. Okay, let's figure out another good point. 4.5 could work, because 4.5 times 2 is 9, but some of you are like, oh, I don't want decimals. I guess you could have tried to go to 8, would 8 be 6? Because 8 times 2 is 16. I guess you could have gone to 80. Let's go ahead and just, for sake of argument, let me show one of the decimal ones just so you guys can see it. Because if you do plug in 2 times 4.5 plus 7, there's supposed to be a point in there somewhere. You do end up with square root of 9, 4.5 times 2, which is 3.
Do 12.5.
Oh, sorry, I did not even put that in the right spot. There we go. Square root of 9 is 3, 3 plus 7 is 10. 12.5 times, yeah, it would be 25. I kind of see the 8 might be easier because 2 times 8, so then I might do that one next, and then I might say, you know what, I bet we got enough. So we don't necessarily have to do a magical number of points, just want enough. Square root of 2 times 8.
16 is 4.
16, square root of 16 is going to be 4, and 4 plus 7 is 11. Jordan, I'm here, you take that ahead. We're going to our graph now, yeah? Now, if you guys look at your graph, technically you don't necessarily need tons of positive numbers. You don't necessarily need tons of positive x's. So I kind of zoomed in over here, so we're starting at 0. Now I'm going to go to 1, 2, 3, 4, 5, 6, 7, 8. Probably good. But we gotta go all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What's different about this one?
Taller.
It's taller.
Yeah.
And I didn't say taller because taller denotes like it's been stretched, right? But it's not taller. It's just been, yeah, it's clustered higher. How do we? It's been raised. Good. It's been raised. Because it's not that they've been stretched. Like some points are still down here. It's not that it's been stretched. The whole thing has been shifted up. So I have 1, 2, 3, 4, 5, 6, 7, 0, 7, right? Then I have 2 going to 9. Then I have 4.5, which would be like here-ish. Going to 10. Starts to level out a little bit. And then I have, I'm starting to run out of room. I'll just move this down a little bit. Then I have 8, which is way out here, going to 11. Going forever only one direction. Now guys, look at this graph. It hasn't been stretched, it's been raised, or we would say translated, shifted up. How should we then describe its range? Why? Because rangy. Here, no. Put that down towards your pencil. It should be right. Y is above, so greater than or equal to, and what is it above? Remember, how low does it go? How low does it go? 7. How left does it go? 0. Yeah. You got it. Questions on range or domain? Questions on graphing? Now guys, why am I showing you all this and why is it so important? Well, last night homework only went to number 20, right?
Yes.
Some of you got stuck somewhere in between. Can I show you real quick? Number 19 and 20 started a new section, but it wasn't like crazy new as in you hadn't seen it before. And homework picks up right here in number 21 tonight. What are the directions of the first section of homework? It was where you ended last night and where you start tonight.
Graph the function and describe it.
Now, pause. And actually, this is a good one for Jordan when she comes back in. In order to graph a function, what makes it easier so we know where to start in our table? Okay. So the directions say find the domain. But what makes it easier? Okay. So even though the directions don't say so, where should you start? In this section. Yeah. Find the domain. It'll let you know where to start your table and then how to keep going. Yeah.
The number 22
Uh-huh.
is the same. Like, you have to find the
Uh-huh.
but then when you put it
Well, when you plug in, you're going to do the square root first because it's grouping symbol, and then you're going to add -2 or -2. Yeah. Kind of like this one, we found square root in the last example, and we added 7. We're just going to find the square root and then subtract 2. Right. We'll see. There's a lot of people leaving this trying to stay put and get some stuff done. So as we have this section, guys, let me zoom out really quickly and show you. There's this section, 21 through, how far are we going in homework tonight? 35? Okay. So then we go to this section. This one says graph and compare. But wait a minute. What makes it easier to graph? Oh, yes.
for an example, like 32, how would you do that?
So which one, 32?
Yeah.
Guys, help out real fast. And actually, hold on, my question ties in with yours, so give me 1 second. Guys, look back up here. This one says graph, and graph means use a table. Stop talking, my turn. Graph means use a table. What did we just say will make this section easier for us to start graphing? Find the domain to make the table. Find the domain. So then, Griffin. Griffin was asking number 32 because it's funny, it's weird, there's like a number on the outside.
Yeah.
How do we find the domain of this one? What's the radical here? Just the x. Just the x is underneath. My marker's really thick and so it blocks it out, but just the x is underneath. So I would say just x, and I actually don't have to do anything. X is greater than 0, there's no moving to do. It was just x. So then where am I going to start my table?
0.
At 0. Does that make sense?
Then it'd be 0 times -5.
And then 0, I take the square root first. square root of 0 is 0, times negative 5. The y will be 0. Now, can anyone help me out? If this is just square root of x, what would be a good next number to plug in? Yeah, 1. Square root of 1, I can do. What's another good number to use?
4.
Well, square root of 2, you could, but how about 4?
9.
Because square root of 4 is 2. 2 times negative 5. So, actually, you know what? Can we just finish this example real fast? It's kind of weird. Okay. When we plug in 1, square root of 1 times negative 5, I know I'm doing a lot of mental math, but can anybody follow me there? Square root of 1 times negative 5? Negative 5. Square root of 4 times negative 5 is negative 10.
No, it's 10.
Oh, never mind.
Because it's 2 times negative 5. Now pause. Can I just show you this graph real fast? It's weird. We could do more. We start at 0, 0. Then we go 1, wait. We're going negative. And then we're going
10.
what? What is? Now, if we kept, yeah, Barry's already like, there's a negative in front, so we're going down. Guys, you've seen functions before that get what we would call, okay, we did have parabolas that went up, and we have parabolas with negatives that would make it go down. Same thing here. We're used to, pause, we're used to square roots going up, but can it also go down? And the answer is yes, pause. How would you describe the range?
Oh.
Less than.
Y is lower, Y is below. Does that make sense? So then Y is less than or equal to. How? So the question isn't how low this one goes. The question is how high this one goes. And how high does it go? Does that make sense? So then I'm just saying square roots don't always have to go up. They always go forever in one direction, but they can also go down. Jazzy, since you're done, why don't you just so you can listen and watch, but you can take notes this weekend. Good question, but actually, guys, let's look back up here real fast. We are supposed to graph, so we can see that, but it doesn't say to do the range next, even though we can see it. It says to compare. What? Now, next thing is, homework question 35 is the last one. So we just need to figure out this section, then we're done for today. Ready? Let's come back to notes. Let's figure out how to compare. Oh, I have this like graph on this. Alright. Check it out, kiddos. Ready? One page, we're done. Okay? So here we go. Let's go ahead and zoom on in. We need to figure out how to do this comparing thing. And the nice thing is these words aren't brand new. I just wasn't very particular last time in the words that you used to describe. I'm going to start being particular because it'll help you in future math for me to actually teach you these words. I think you saw them with Coach Trapp, right? Towards the end of first semester. I said things like shifting, or up or down, or right or left, stretching. We're going to try to go ahead and be a little more precise right now. So here's what I need you guys to do. I need you to, I know it's annoying, but this is like the last little bit of words to write down. Then we just have examples until the bell goes. And if we can stay focused, no extra time today. Look, look, look. Look, look, look. Shh. These are the words you're going to need to use in that section of homework that says compare. Okay? Horizontal or vertical translation, reflection, horizontal stretch or shrink, vertical stretch or shrink. Start writing, and then Josh, sorry. I was trying to get them going before I answer. Go ahead.
Oh, no, I was just going to say I have a headache, so like, I was going to ask you something.
There's actually, for some reason, an extra thing of lights got turned on.
Yeah, I noticed that. It's so weird.
I think someone last class did that, so let's see if that might just help have a little less tension on your eyes. Transformations. These are the comparing words to use. Remember, like, not even remember. Think about English. Whenever you're trying to learn vocab, you know how sometimes you have to like write it in a sentence. Okay.
Yeah.
Same thing here. I'm giving you the words to write in the sentences for homework. We just have to figure out which ones apply to the types of equations we have. So we have the words. We have what they look like in snazzy function notation. And I'm going to actually make this a little easier because it's kind of hard when there's an f. All of these are square roots. So let me show you what I mean by f of x minus h. It means that there's going to be an x minus h inside the radicand. Whereas this one says there's going to be a plus k on the outside of the radicand. All these are square roots. I'm trying to make it particular to square roots. So if you want, you could go ahead and not write the function notation. Some of you might want to see the function notation. It is helpful for future math. But you can also just use the square roots if you want. This one, you're either going to have a square root under or inside, or you're going to have, I apologize, a negative under or a negative outside. That's what's going on here. This one, you're going to have an ax under or inside. And then this one, you're going to have an a outside. So if you guys want, you can skip writing all of this function stuff and write the square roots instead. But the function is good to see for some of you as far as future math. You can stay focused. I'm really trying to get us out of it. No, let me help out real fast. There are examples. All of these are examples. And basically, guys, if you get these examples, you're pretty much good to go. Because these examples are, well, maybe homework will look like this problem, or that problem, or this one, or that one. And how would you say, or how would you compare? So all of this is how would you compare. How would you use these words to compare whatever function you have, whatever, I would say, transform function, like transformers, right? These have been mixed up, they've been changed up, they have addition, or they have subtraction, they have multiplication or division, they have negatives. They've been transformed. So compare the transform function to, this is what we're trying to answer. Compare the transform function to the parent function. How do these compare? Okay. How do these compare? Let me go ahead and help out. I would say the very first function, which is this top one, square root of x minus 2, that compares to the original in that whenever you have a minus or plus inside the radicand, there is a shift left or right. And let me show you which one's which. And I said this the other day and you guys got really confused. So maybe you forget it from what you learned earlier this year. Whenever there is a minus, the formula has a minus. So the minus is a part of the formula. The 2 is what got plugged in. The 2 is positive, so we say that it has a shift, the plus or minus, to the right 2. Whenever there's a minus on the inside, we say it's a shift right 2. Whenever there's a plus on the inside, well, if it's not right, what must it be doing? It's going the opposite way. So whenever you have a minus underneath or inside a function, in this case square root, the minus actually is backwards what you think. It's going to the right. It's moving to bigger numbers. And then the plus is shift left. Jordan, go ahead.
For a reflection, it says square root negative 1, but you can have a negative number squared.
But think about what number would be legal to put in. We couldn't put in a positive 1, 2, 3. Negative. So it flips what x's, well, technically we usually use positive x's. It flips what x's we can use. Now we can use the negative.
So you can put negative one.
Yeah, exactly. Does that make sense? Because you have a negative, you put in a negative. Oh, now negative 1's okay. Before it wasn't. For these ones, guys, the vertical translation or shifts, those ones actually work a lot more like we think. Vertical means up or down. So in this one, we're going to say shift, the plus 7 is just up 7. These ones work the way we think they should. Plus 7, oh, okay, then we're going, if it's up or down, we're going up. If you're subtracting one outside the radical, you're going to be shifting, if it's not up, where's it going? The minus means you're going down. So where it gets a little weird, but some of you guys, Jordan and Ian both just brought up, this negative underneath looks really weird, but if you think about a table, x could be a negative 1. Oh, so instead of x's being over here on the right, x's are over here on the left. We can say this is a reflection we would technically say this is where it gets a little weird, in the y-axis, it's actually the same thing as, here's your y-axis. You're saying whatever was on this side of the y, think of like if you fold your paper, it'll now come over on this side, so it is a paper, and if you fold it, y-axis means the y is the fold, and whatever is on this side comes over on this side. So whatever were the positive x's, now the negative x's were. We also call it a horizontal flip, because you're flipping this way. Whereas if it's negative on the outside, we call it a reflection in the x-axis. Because if you think you plug in like x is 1, instead of going up to a y, there's a negative that's going down to a y. So if you plug in 1, square root of 1 is 1. Backwards and forward this way, side and forward. Square root of 1 is 1, but if there's a negative on the outside, just chilling, waiting for it, well, it's not going to go up to a y, it's going to go down to a y. So the y values are all going to flip around. And the last two, so we talked about, first of all, translations. Second of all, we've talked about reflections, which are flips. If you guys want, you can also think about the words that explain what these do. Reflections are flips, whereas translations are shifts, right? So the very last one is going to be stretches and shrinks, which, I mean, that's literally what the words are, right? Stretch and shrink is what they use down below. So, over here, if there's a 3 underneath the square root, it's going to be stretches or shrinks away or toward the y-axis. We're going to say that if it's underneath, the graph shrinks. This is where it gets a little weird. Shrinks. You could say horizontally. Shrinks horizontally by. It's actually going to be not 3, but 1 over 3. Shrinks by 1/3. So the bigger the number underneath, it's going to be a shrink by 1 over that number. And then the smaller that number is, 1/2, it's still going to be 1 over that number. Does anybody know what the reciprocal of 1/2 is? Yeah. You can think 1 over is the same as flipping it. So if you see a 1/2, it's actually going to be double. And horizontal, so shrink is going to get narrower and get pushed in, stretch is going to get pulled out. Vertical, just like kind of up above, vertical works the way we think it does. If there's a 4 on the outside, we're going to say, hey, there's a vertical stretch by 4. Even this is at the end of class.
Backward in a row.
Oh, must be an update or something. Must be an update or something. Here we go, come back. It's okay, it's okay, it's just Sorry, guys. I try to leave it to the end of class, but then I literally forget like I did yesterday, and that's not good. So I have to do it now. You guys just need to stay focused. If there's a 1/5, it's going to be a shrink. Now, I know it's a lot of words, but what I'm hoping is that you guys actually use your notes when you do your homework. So if you have all these words, maybe you can come down, and if you're asked to graph, well, you're going to find a domain and make a table. But if you're asked to compare, which is what these directions say for the second half graph, okay, we're going to find domain, this is table. Compare. Can you guys fit this in a certain category? Look at this function h of x. Fit it in a category. What's going on with that 1/4? What is it changing? Look at the table. Look at the table. 8, look at the table. 1/4 times x. What's the 1/4 doing?
It's stretching.
Not a plus or minus.
Oh, you got it. So
It's not a negative. Wait. Is it outside or inside though?
Inside.
It's inside. So what kind of stretch or shrink? Horizontal. Now is it a big number or a little number? So it's going to stretch. Look, you gotta match it. Does that make sense? Match it. Inside, with a fraction, it's going to stretch by
4.
Yeah, this is a 1/2, and we flipped it to get the 2. Down here, this is a 1/4, and we're going to do what? Flip it to get the 4. Good. So we can say this is going to, ready? Horizontally. Or you could say it has a horizontal stretch by fill in the blank. So each of these up above, guys, the numbers that we actually put in, pause, I'm gonna let you go. The numbers that we put in, that might change. Based on the problem that you have. That might change. That might change. But you're gonna take the function, you're gonna fit it in the table, where does it go? You're gonna use the comparative words that I showed in Model D, okay? I want you guys to go ahead and show me that you have the homework, either taking a picture of it or written down somewhere, and I'll let you go. Go ahead. Josh? Oh, you need your phone? Okay. Rod, what are you doing, bud? Thank you, thank you, thank you, thank you, thank you.
I just took a picture of it.
Perfect, thank you, Jordan.
Like a fire, fuego.
Got it, I saw it. Are you guys keep writing it? You're good. And you got it, good thing. Okay, you're getting it?
Is it? And can I take a picture? Yeah.
Oh, yeah.
Yeah,
Perfect. Jazzy, get a picture or write it down. Oh, you already got it? Okay.
but.
Let me stop the recording.
Need proof?